Hi, it's Dr. Nigro, this time talking about changing velocity. All right, when you change your speed or your direction, all right, then you are changing your velocity. The rate at which your velocity changes is known as acceleration. All right, so this is going to be a new variable for us. All right, and acceleration equals the change in velocity over time. So again, it is a rate, so that's why it's per time, all right? Which means acceleration is the change in velocity over time. Now, this change in velocity, this delta V, all right, is equal to the final velocity minus the initial velocity. So we most often see acceleration as equal to V final minus V initial divided by time. All right, now let's talk units. All right, your velocity values that show up as V final or V initial should be in meters per second, just like we saw before. Your time should be in seconds, and your acceleration is going to be meters per second squared. All right, for our formula triangle, V final minus V initial, also known as delta V, up top, and then we'll have acceleration and time. So if we solve for our three variables, right, acceleration is going to be equal to V final minus V initial over T, all right? I'm just going to put V final minus V initial, M for delta V, because we don't tend to use delta V all that often. But that's going to be equal to acceleration times time, and then time will be equal to V final minus V initial over the acceleration value, all right? Now, just like our other problems, when you're working acceleration problems, you got to watch those units and you got to make sure that those units match each other and what the problem asks you to do. You also need to watch out for things like from rest, to rest, stopped, and constant. All right, from rest, to rest, stopped, these give you info about your velocity values. All right, if you're starting from rest, that means your initial velocity is 0. If you go to rest, that means your final velocity is 0. If you're stopped, that means you're not moving, your velocity value is 0. If it tells you you have constant velocity, then you have no acceleration. All right, if your velocity is constant, that means it can't be changing, so you can't have any acceleration. All right, now just like velocity, all right, acceleration is a vector quantity, all right, and can be positive or negative. So it has direction, all right. The sign tells us what that direction is, all right. It does not mean that the acceleration is greater than or less than 0. It just tells us in which direction the acceleration is occurring, all right. Now, you must compare the direction of the acceleration and the direction of the velocity. So we need to look at the signs of these two variables to know whether an object is speeding up or slowing down. All right, there's a general rule of thumb about these. If the signs of these two variables, acceleration and velocity, match, all right, so both positive or both negative, all right, then the object is speeding up. All right, if the signs of acceleration and velocity do not match, all right, so in this case, one's positive and the other is negative, then the object will be slowing down. All right, so if you're trying to determine whether an object's speeding up or slowing down, I suggest that you look at the signs of your velocity and acceleration values and make that distinction. All right, so let's look at each of these situations. All right, so we're going to start where we have a positive velocity value and a positive acceleration value. All right, so here's my person. All right, the positive velocity value tells me that that person is moving forward. All right, because remember, the sign of our velocity value tells us that direction. All right, if our acceleration is also in the same direction, then the acceleration and the velocity, they're working together. And if they work together, then you're going to speed up. So if we have a positive velocity, we are moving forward. All right, and if the acceleration is also positive and the signs match, then we are speeding up. All right. What about if we have a positive velocity but a negative acceleration? All right, so this time we have our friend. All right, he is moving forward. And I know that he's moving forward because the velocity value is positive. But his acceleration is happening in a negative direction. So what does that look like? All right, if you're biking, for example, and you're pedaling forward, all right, but you apply the brakes provide friction in the other direction. All right, so that's going to slow you down because the velocity and the acceleration, are working against each other. All right, and because of that, you cannot speed up. All right, so in this scenario, the object is still moving forward because of the positive velocity value, but they are slowing down because the two signs, the acceleration and velocity, are working against each other. All right? All right, so now let's switch. Let's say instead the velocity is negative and the acceleration is positive. All right, so in this case, we've got our person. All right, the person is moving backwards this time. And I know that because my velocity value is negative. But their acceleration is positive, so it's in the opposite direction. All right, so velocity and acceleration work against each other. Oops. All right, so the object is moving backwards because of the sign of velocity and slowing down. All right, our last scenario is if the velocity is negative and the acceleration is negative. All right, so in this case, our friend is moving backwards. All right, and again, we know that because the sign of velocity was negative. All right, but in this case, their acceleration is also negative. All right, so the velocity and acceleration work together. They cooperate. All right, so this object is moving backwards because of that negative velocity, but because the velocity and the acceleration work together, it is speeding up. All right, so again, the sign of the velocity is going to tell us our direction of travel. A comparison of the signs of the velocity versus the acceleration tell us if the object is speeding up or slowing down. Okay? All right, so that's the notes for this portion. All right? We're going to talk in another video about the different graphs that go along with these different types of motion. All right, and then in our next unit, we'll be talking about constant acceleration and free fall.